Welcome, Joe Gamers. New year, new gaming, alright? So, today we'll be learning Calc 3 intro, and it's gonna be about vectors, alright? Alright, let me see my notes here. Got some notes here. Alright, so let's start with defining the space we'll be working. So, traditionally, we usually worked within the first dimension and in the real numbers, and the second dimension real numbers, which is kind of represented by a number line in the first one, and the second one would be a coordinate 2D grid like that. So then that would mean on the third plane there would be three axes that are perpendicular or orthogonal to each other. Right. Yeah, so usually when we draw it like this, x is here, y is here, and z is here. And usually we work in y and x with the second 2D plane. The 3D plane, this plane turns into here. And we got 8 octaves, kind of like quadrants. Like how this has 4 quadrants, first, second, third, fourth. Now there's one in the positive, all positive side, two second octave, third octave, fourth octave, and then the bottom, fifth, sixth, seven, eight, six, seven, six, seven. Anyways, that's enough about the defining stuff. That doesn't matter. So, most fundamental thing is in vectors is distance. So distance in 3D in the R cube dimension. Alright, Catherine. Is defined by x2 minus x1 squared plus y2 minus y1 plus z2 minus z1 squared and square root it off. Pretty obvious, I would say. And so the definition of a vector is an element that has a magnitude and direction. So magnitude as in length, direction as where it's pointing. So the magnitude is how long the length is relative to itself. And the magnitude is, the direction is where it looks at. Look here, what angle, the direction. I think it's kind of obvious, but yeah. And hold on, let me go back. This right here is called the initial point, and the arrow part is called terminal point. Terminal point. Okay. So this is kind of obvious, but anyways, crap. So vector notation and variables kind of looks like this: the letter and an arrow at the top equals, and then this bracket, and we put A, comma B, and if there's a third, fourth, fifth, whatever, usually up to third, but for now, A, B, C, and we define its magnitude or its distance from the initial point to the terminal point as this, absolute sign value or a double one, just to make sure. And that's equal to a squared plus b squared plus c squared. There you go. Since the distance between the two, distance between a vector and nothing is 0, that is why a squared plus b squared is c squared. Or this can correspond to x, y, and z. Alternatively, you can rewrite it in this format: I times a plus b times j plus c times k, where there got vectors on top of those, and those vectors correspond to unit vectors. So this is I. Oh crap. This is j, and this is k. Now, um, the basic rule about vectors, especially in addition, is that you can just add them, just straight up add them in their own distinct spots. So 1 plus 0, 0. The new thing, it would be 1, 1, and 1. And if there was an A, what the hell did I draw here? B and C, it would just turn into A, B, C. Now, to further emphasize my point, A, B, C, and U vector equals D, E, F. V vector plus U vector equals A plus D, B plus E, and F plus C. Yeah, let's see if that's all for now. Should I end it here? How much time is it? Is a good enough end for this low key? Yeah, it's a short introduction to vectors, I guess. Tune in next time for multiplication and stuff, I think. Yeah, alright. Alright.